In this video, we will see dry run of the code. Now let's quickly do a dry run of the code. The basically both the approaches we have discussed. Let's do a quick dry run of this. Okay. So let's start equals to intervals dot map. So basically I'm mapping it here. So how this will work, I will simply create one start array and I will map all the starting time and I will sort it. See, both the things are happening. So I will do it one time. I will map it and I will sort it. So 0, 6, 3, 1, 8, 12. So I will write 0. Then I guess 1 should become. Then 3 should become. Then 6 should become. So 0, 1, 3, 6, 8 and 12. So this is basically how you map the starting time and there and sorted. Similarly, the ends time. Okay, so I have 4, 10, 7, 4, 12 and 14. So 4, 4, 7, 10 and 12 and 14. These will be the starting times. Okay, let me write the indexes 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Okay, now I will take one max variable. So max is equals to 0. I will take count, that is count is equals to 0. I is pointing to 0. So suppose I have two pointers. Let me create some space and add the pointer. So I is pointing here. J is also pointing here. Is I is less than intervals dot length? So yes, intervals dot length. Yes, intervals dot length is 5. Okay, both the intervals is same. So here instead of intervals dot length, you can also put starts dot length. Basically both are the same things. Okay, but it should be more towards the start dot length. Okay, but let's see. Both are the same thing because here also 5 indexes, here also 5 indexes, right? So the length is here total element 6. Yes, so I is less than 6. Is the start time of I is less than ends time of j. So yes, 0 is less than 4. So what I will do, I will update the count to 1 and I will move my I pointer. So I will move my I pointer. Okay. And my max now will be updated to 1. Okay. After this loop, again I will check is starts of I is less than ends of j. Yes, it is. So I will update the count and I will do I plus plus. So I pointer will move and my max will also be updated to. Right. So see, I am doing these three things. Okay. Again, I will check is start of I is less than ends of j. Yes, start of I is less than ends of j. Again, what I will do, I will do count plus plus. Count will be 3. And I will do I plus plus. So I will be move ahead and I will do max. So max will be updated to 3. Okay. Now I and j. Again, I and j. Is it still less than here? Just give me a second. Yeah. So yeah, is it still less than ith start of I is still less than ends of j? No, it's not. Okay, I will come under the else condition. I will decrease the count. Count will be 2, max will be same, and my j pointer will move. Okay, now here, is it still less than? Is the jth term is less? So yes, jth term is less. You will come under else condition. You will decrease the count, and the max will be same, and you will move your j pointer. Now I and j, which is less? So I is less, right? Start time is less. So you will update the count and you will simply do I plus plus. I will be here. Okay. Max will be 3 only. Now 8 and 7, which is less? 7 is less, right? You will come under else condition. You will decrease the count and you will simply do j plus plus. Now 8 and 10, which is less? So 8 is less. What you will do? You will update the count plus plus and I plus plus. I will be here. Now again I and j, which is less, so j is less. What you will do? You will simply decrease the count and you will move j pointer plus plus. Now here 12 and 12 both are equal, right? So if even if they are equal, you will come here count minus minus. Okay, you will move count equals to 0 and you will move your j pointer. Now I and j, right, which is less, I is less. So basically what you will do, you will update the count, max will be same and you will do I plus plus. And here I reached to the limit. Okay, the maximum we got 3. So the maximum room or like the minimum conference required will be 3. So don't confuse with this max. I am saying max, but I am calculating. I need to calculate minimum conference room required. Basically, this max means the maximum overlapping at a time. Okay. So let me explain you. One interval is from 0 to 4, like this. One interval, if I sort the data, so 0 to 4, and I will get one interval from 1 to 4. So suppose here to here, 1 to 4, and one interval will be from 3 to 7. So from here to suppose here, and one interval from 6 to 10. So somehow here to here, 6 to 10. One interval from 8 to 12. So it is here 12, and 1 12 to 14. Okay. So the maximum overlapping at a time that is happening, basically this is what max is. So here you can see, okay, from 3 to 4, the maximum overlapping here I am getting, that's a 3. So here for this period of time, I want 3 rooms required. Okay, that's why the minimum conference room is 3. Okay. So here you can see 0 to 4, then 1 to 4, and 3 to 4, right? So if this happening, like you will take one room for this one room for this one, and one room for this one. And then the same room can be used by 8 and 12. Okay, the 3 7 wala room. And then 1 to 4 can the same room be used by 6 to 10 and 12 to 14. Right. So yeah, this was the dry run of it. Okay, let me put dry run. Okay, now let's do the dry run with the approach 2. Okay, so basically we need to sort the intervals according to their starting time. So let me first sort the intervals. So if I sort the data, let me put the yellow color. If I sort the data, it will be 0 to 4, then 1 to 4, then 3 to 7, then 6 to 10, then 8 to 12, 12 to 14. That's it. Okay. Now I will take priority queue. So this is my priority queue P. Okay. Priority queue. And I will simply start from intervals. So suppose this is my ith interval. I will start from here. Okay. I will check is P is empty. Okay. If P is not empty. So first of all, it is empty. So I won't come here and I will add the interval I. So I will add the ith. Sorry, I should add here intervals I comma 1. Okay. So basically intervals I comma 1, that means I will add 4 here. Okay. Once I have added 4, right, I will move my I pointer will move to here. Okay. I will I will check is P is not empty. First of all, this is my P priority here. It's not empty. So yeah, it's not empty. And P dot peak, that means 4. Is it lesser than the intervals 0? Intervals I comma 0. Okay. First of all, this is, let me take that instead of, because here there is no I, this not be intervals, it will be interval, right? Because I am taking here interval, right? So it will be interval. Okay. Yeah. So we have 4 here, and yeah, 4 here. Now I will check is 4 is lesser than equals to starting time. So no, right? This condition is not true. 4 is not lesser than. Right, basically this time should be greater than, so that we will add it. Okay, but this is not lesser than, so what I will do, I will add it here, and I will add the one term, that means I will add the 4 term here again. Okay, so again, right, this priority queue will sort it, and the topmost element will be same itself, 4 only. Okay, now I am getting the next 3 comma 7. Okay, I will check is my P is not empty. Yes, it's not empty. And your peak is lesser than the starting time. No, it's not. It's not lesser than the starting time. So I will add 7 also here. See, I am adding 7. Why? I am always ending end time. I'm always ending end time here. Adding end time. Okay, so I have adding end time. Okay, and see, whenever I am adding end time, it will sort itself, right? So how my priority queue will be 447. Okay, basically priority queue will always point to that element which is ending first, right? The earliest ending. So 4 is ending first. Okay, I will move ahead. Now 6, 10, right? Is P is not empty first of all? Yes, it's not empty. Is P dot peak is lesser than my ith starting time? Yes. Okay, so it is lesser than. So what I will do here, I will P dot poll, I will basically remove this one, right? And I will remove, and what I will do, I will add this interval. So I will add this interval, I will add 10. And once I have added, again I will sort it basically. So I will sort it. So it will be 4, 7, 10. And I will move ahead. I will again check, is P is not empty? Yes, it's not empty. Okay. I will check, is P dot peak is lesser than the your next interval starting time? Yes, it's lesser than. So what I will do, I will do P dot poll, I will remove it. I will remove it and I will add the interval one. So I will add 8. And again, once I have added, this is a priority queue, so it will sort itself. So it will become 7, 8, 10. Okay. Now again, I will check the next interval, that is 12. Okay. Is your peak is lesser than the starting time? Yes, it is lesser than. So what you will do, you will do P dot poll, you will remove this one and you will add 12. And once you have added 12, what you will do, you will sort itself, you will sort the way. So it will become 8, 10, and 12. Okay. And yeah, that's the end of it. Okay. And what you will do, you will return P dot size. What is the size? Size is 3. So answer will be 3. Right. So basically we are able to solve it when we have a priority queue, because priority queue sort itself. Okay. On each iteration, whenever we are doing P dot poll, whenever we are doing P dot add interval. Okay. So yeah, this is how we basically solve this problem by two approaches. I have discussed both the approaches. Okay. So yeah, if you like this video, if you like both the approaches, yeah, please stay tuned on this course. Okay. Check out my next video where I have discussed more problems on the internet.